goal for today is going to be to learn how to graph sine and cosine equations. Okay, so overall, you don't really need a calculator for this, but it might make it easier. So if you don't have one, go grab one. Go ahead, Alex. What do you need? Oh, here. All right. Okay, so normally, I would have you get out your circle and look up a bunch of these values, but because it's Friday and we're all, tired, I'm just gonna give you the graph. Okay, so along the x-axis, you're gonna count by 90-degree intervals. So 0, 90, what would come next? 180. Okay, add 90 again. And then one more, 360. Okay, then, thank you. If you were to look at your unit circle and trace the cosine values around the outside, here's what you would find. At 0, it's 1. We'll go ahead and put a 1 here. At 90, it's 0. At 180, it dips down to -1. At 270, it's back to 0. And then at 360, it's back to 1. Okay, and then as you go around the circle, because it is specifically a circle, you're just going to repeat that cycle over and over again. So your cosine graph goes like this. And then it's going to keep doing that going forward basically forever. So I'm going to just kind of sketch in that that's one full wave, but this pattern would continue. Okay, little arrows on both sides. Okay, all the way to the end of the graph, basically. Okay. So this is the parent graph for y equals cosine x, and it starts at its highest point on the wave. Okay, so y equals cosine x, it's going to start at 1. Okay, and then you're going to go through wave after wave after wave, blah, blah, blah. Okay, let's go through some terms. Amplitude, okay, right here is the height of the wave. Okay, so in this case, your amplitude is 1. Okay, that's for the parent function. Okay, a period is how long it takes one full wave to happen. So if I start here and I go through one full wave, it took me how many degrees? 360. Okay, so one full wave, it takes 360 degrees. Okay, then your domain is going to be all real numbers. Okay, and the reason why is because even though it takes 360 to go through one full wave, remember what I said, this pattern repeats itself all the way till forever. But your range, you have a highest and a lowest point. What's the lowest the graph can go? -1. What's the highest? +1. So your range would be -1 is your lowest, +1 is your highest. Okay. And then what we're going to do with this is we're just going to do transformations on it. But the good news is that all the functions we've done this on, the rules stay the same. So if you have a number here in the front, okay, A controls if it's a stretch or a compression. Okay, remember that it's a stretch if your A is greater than 1, and it's a compression if your A is less than 1. Okay, this also determines the amplitude or how tall your wave is. Okay, so it's kind of nice that the letter's A and it stands for amplitude. Okay, the next number is going to be the number in parentheses with the theta. Okay, in this case, they use a C for that. Okay, and that's your horizontal shift. Okay, specifically for trig, it's also called a phase shift. Okay, but think about your phase shift is just left or right. Okay. left or right. Okay, then your direction is always going to be the opposite side. Okay. And then I actually don't know what goes in this blank, so just ignore that. All right, your vertical shift is going to be the number, the plus D at the back. Okay, that is going to determine the shift up or down. And then this one is going to be direction is always the same sign. Oh, that should have been. Okay, direction is always the same side. So for the one in the parentheses, you're going to reverse it. But for the one at the back, you're just going to do what it says. If it says plus go up, minus go down. Okay, once you're ready, go ahead and turn the page. Let's work a couple examples. So on the next page, you have y equals 4 cosine beta minus 10 plus 1. Now, this cosine shouldn't be here twice, so if you want to just scribble that out. Okay, which way am I going to shift the graph if there's a minus 10 degrees inside the parentheses? Left or right? Based on what we just covered. Minus 10, which way do we go? To the right. Okay, to the right, 10 degrees. Okay, so instead of me starting my graph at 0, I'm going to start my graph at 10. But then remember, I'm going to still count by 90. So in your calculator, if you need it, what's 10 plus 90? 100. Plus 90 again, what's the next one? Very good. What's the next one? 280. And then last one is 370. Okay, so I'm still counting by 90, but I'm starting at 10 degrees. Okay, then from there, we need to look for our vertical shift. That's this number at the back. So you have a plus 1. So you're going to go up 1. And then I want you to draw in a dotted line. Okay, this is now going to be the middle of your wave. Okay, like that. Okay, then from there, look at the number in the very front. Okay, we have a 4 here. Will that be a stretch or a compression? Stretch, my amplitude is going to be 4. So starting at 1, I want you to count up 4. 1, 2, 3, 4. What's the highest point on my wave going to be? 5 is correct. Very good. Then you're going to go back to 1 and you're going to count down 4. So when I go down, I'll be at 0 is my first point, then 2, 3, 4. What is my low point going to be? If I start at 1 and I count down 4, what will this bottom point be? -3. Okay. But the reason it's not -4 is because remember, I was already at 1. Okay. From there, you're going to put your marker dots. Remember, cosine starts at the highest point. So your first point is going to be at 5. Then it will hit what's called your midline. Then it'll hit your low point. Back to midline, and then at the top. Okay, once you have those 5 points drawn, you can put in your wave. So it's going to go down, up. Okay, but then remember, like we talked about, technically this wave goes on forever and ever, both ends. Okay, you're doing one full period, which is 360 degrees from 10 to 370. Okay? All right, let's do number 2. Look at the equation for number 2, and I want you to tell me what's different. It's almost the exact same equation, except for what? The negative on the 4. So let's regraph this. So I'm going to put my marker dot is going to be at 1. That's my baseline or midline. I'm going to go up to 5, down to -3. And then I'm not going to relabel the x-axis, but it would be the same. Or maybe I guess I will. So it would be 10. This is 100, 190, 280, and 370. Okay, I just want you to think about, what does the negative in the front do when you're graphing? It does what to it? Flips it. So instead of my cosine graph starting at the top and doing my wave down, it's just going to make your wave start at the bottom and then do the wave up. Okay. So I'm going to put right here, all of this is the same. Okay. But the negative is going to flip upside down. So my wave is going to go like this. You're going to start at the bottom, middle, top, middle, bottom. And then once you have it, just whoop, there it is. Okay, and then we know that that same pattern is going to repeat, okay, forever. So if you want to just put arrows on both ends to show that. Okay. All right, one more cosine graph. Take a look at number 3. First question, I have a plus 30. Which way does that shift my graph? Okay, to the left 30, which means my graph's going to start at negative 30 degrees. Okay, now in your calculator, type in negative 90, or sorry, negative 30, and then plus 90. What's the next marker? 60. Add 90 again. What's the next one? 150. Add 90 again. 240. And then last one, add 90. 330. Very good. Okay, so because I'm not starting at 0, it still takes me 360 degrees, but I'm going to end at 330 because I started at negative 30, if that makes sense. All right, which way are we going to shift with the 3 in the front, up or down? It's a plus 3, up. So go up 1, 2, 3, draw in your midline. And then what number will control my amplitude for this one? The half. Very good. And if it's smaller than 1, instead of it being a stretch, it'll be a compression with an amplitude of a half. So if this is 3, then my wave is only going to go up to 3.5. So put a dot kind of like halfway between 3 and 4. And then it's only going to go down to 2.5. Okay, which is going to be kind of hard to graph because I didn't make much space. Okay, then remember your typical cosine graph, it's going to start at the top of the wave. So you're going to go top, middle, bottom, middle, middle, top, like that. You should put it on my desk. Thank you, Barrett. Okay, and then draw your graph in. So it should just look like that. Okay, but you'll notice it's still the same wave shape. Just since your amplitude is smaller than 1, it compressed your wave to be shorter. Okay, however, your period that it took to go through one full wave is still 360. Are we good on that? All right, go ahead and turn the page when you're ready. So you've done several cosine graphs. The only other equation that you should know, that you will know by the end of this lesson how to graph is sine. So we're not going to do tan and secant and all the other ones. Okay, the sine parent graph, go ahead and turn the page. Okay, we're going to label our x-axis 0, 90, 180, 270, and 360. Okay, just like last time. Your graph is still only going to go up to 1 and down to negative 1. But the only difference between a cosine graph and a sine graph is that your cosine graph starts at the top of the wave, and your sine graph is going to start at the midline point or the center. Okay, so put your first dot at 0. Then you're going to go up to 1, back to 0, down to negative 1, back to 0. But you'll notice the graph looks exactly the same as far as the wave goes. You're just starting at a different point in the wave. Okay, and then connect your dots. Okay, that would still be one full period. So it's still 360 degrees. Still goes up to 1, down to -1. It's just your starting point that's different. Okay, so I'll put here your period is 360. Okay, and then if you want to kind of extend it here. All right, all of this stuff is the same. So let's go down to the next example. Okay, take a look at number 4. Which way are we going to shift our graph? Forward or backwards 20 degrees? If it's a plus 20, remember that's the opposite one. You see how it's in parentheses? So rather than going forward, I'm going to go to the left, which means this is going to be -20 degrees. Add 90 to that. What's my next marker? 70. Add 90 to that. 160. Add 90 to that. 250. And then last one would be 340. But remember, from here to here is still 360 degrees. You're just not starting at 0. You're starting at -20. Okay, I have a +4 at the back. That's going to shift my graph up 4. So count 1, 2, 3, 4. 4 is your midline. What's my amplitude?
3.
3 is correct. Is that a stretch or a compression? Stretch. And then I'm going to start at my 4 and I'm going to count up 3 to see where the top of the wave is going to reach, and then down 3 to see where the bottom of it's going to reach. So up 1, 2, 3 means 7 is my high point. What will my low point be? 1 is correct. Then remember, cosine, you would start at the top, but sine, you're going to start at the center. So put your first dot right here in the middle, at the midline. And then you're going to go up to 7, back to 4, down to 1, back to 4. And that would be one full wave. Okay, and then if you want to do it again, you can. Okay, the domain for this one would be left and right. What is it? All real numbers is correct. But then for your range, what's my low point this time? 1, and my high point is 7. So it'd be 1 to 7. Good? All right, we'll do one more like that. Oh, okay, never mind. Look at number 5. Can you tell me what number is different that we haven't had in the past examples? The 10 is new. Okay, but everything else is the same. So for right now, let's just ignore the 10. Pretend it's not there. Okay, which way are we shifting? Left or right? It's a -5, so I'm really going to go to the right. So I'm going to start at 5 degrees. Okay, and then don't add 90 to get the next numbers. We're going to leave that off for now. Are we shifting up or down? Up, how many? 1. Now you'll notice this 1, if you don't like it here, just move the +1 to the back. Okay, whether they put it at the beginning or the end, if they're adding it, that's your up or down shift. So we're going to go up 1. This is my midline. And then what is my amplitude going to be? 2. So if I'm starting at 1, I would go up 2. That means my top value is a 3. I could also go down 2, which means my bottom value is a -1. Okay, because I'm starting at 1, I go down 2, that puts me at -1. Okay, then go ahead and do your graph. This is a sine, and we know that sine starts in the middle. So you would start at 1 up to 3, 1 down to -1, then back to 1. Okay, and then draw a new one. Okay, normally it takes how many degrees to go through one full wave? 360. This number, this 10 right here, okay, changes the period. So if they put a times 10 here, your new period is going to be 360 and then the opposite of what this says. So if they say to times by 10, what are we going to really do? Divide by 10. And what is 360 divided by 10? 36. So my period is 36 degrees. Okay, then to know what to count by along this axis, you're going to divide that by 4. Okay, to divide it into 4 pieces. So what is 36 divided by 4? 36 divided by 4 is 9. Very good. So what that means is that when I label the x-axis, instead of adding 90 each time, I'm only going to add 9. So 5 plus 9, what's this? Close. Plus 9 would be 14. Add 9 again. To be 23. Okay, add 9 again. 32. Add 9 one more time. 41. Thank you. Okay, and now think about, okay, overall, from 5 to 41, that took 36 degrees, which is what the period was supposed to be. Okay, then last thing on that, if you are doing a horizontal stretch or compression, a stretch would make the period longer, a compression would make the period shorter. So if the period used to be 360 and now it's only 36, which would I circle? Compression. Okay. Then I didn't finish filling this out, but we did a stretch with an amplitude of 2 and our shift was up. Okay. All right, let's do maybe one more like that. Take a look at number 6. I have a +4 in parentheses. Which way are we shifting? Okay, +4 means to the left 4. So I'm going to start at -4 degrees. Okay, then I'm going to finish out the cosine before I go back and label the x's. So I have a -12 here at the back. Are we shifting up or down? Down 12. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's my midline. Okay, that's where my wave should kind of center around. Okay, then what's my amplitude going to be? 20. Is that a stretch or compression? Stretch, because remember, your parent graph, the amplitude of the wave is only 1. So if I turn it into a 20, that's a stretch. Okay, if I type this into your calculator at -12. Type in a -12. And now I want you to add 20 to see how high it's going to go so that we don't have to count it. What is -12 plus 20 for the high point on the wave? 8 is correct. Now, if you want to actually count it out, fine. Okay, but if you start at the midline and you add 20, that'll give you the high point. How will I find the low point? -12 minus 20. So what is -12 minus 20 for the low point? -32. Very good. Because remember, the amplitude tells you how high or low off that midline you're going to go. Okay, then from there, this is a sine graph. Does it start at the top or the middle? Sine starts at the middle. So I'm going to be at -12. Then I'm going to go up to 8. Then back to 12. Then down to -32. And then back to -12. Then once you have those 5 dots, you're just kind of drawing in your wave. Yeah. I'm recording it right now, and then I'll send it to you. Okay, from there, let's check our period. How long is the period normally for the parent graph? 360. So start with 360. And then which number is going to change that? They put a times 30, which means we're going to really do what? Divide by 30. Very good. So what is 360 divided by 30? 12. So my period is 12 degrees. And then my steps, I'm just going to divide it into 4 equal pieces. So what is 12 divided by 4? 30. Okay, so that means that we're going to add 3 each time. So this is a -2. Put it in your calculator. Or wait, sorry, I read that wrong. That's a -4. Add 3 to that in your calculator. What's -4 plus 3? -1. Add 3 again. What's my next bar? 2. Add 3 again. What's my next one? 5. Add 3 again. 8. And now think about, if I go from -4 all the way to 8, is that a full 12 degrees? Yes. Okay. So let's put from here to here is the period, which is 12 degrees. But it's ending early at 8 because it started early at -4, if that makes sense. Okay. All right, we're just going to do one more where we have a fraction. So let's skip ahead to number 8. Last one. First question, which way are we shifting? Left or right? Number 8. To the right, how many? To the right, 150. So label your first spot 150 degrees. Are we shifting up or down if I have a 3 in the front? Up 3. So you're going to go up 1, 2, 3, draw in your midline. What's my amplitude? 5. And that would be considered a stretch. If I do 3 plus 5, what's the top of my wave going to be? 8. And if I do 3 minus 5, what's the bottom going to be? -2. Very good. So remember, if you start with your 3 and you add 5, that's the top, minus 5, that would be the bottom. Okay. Then from there, this is a cosine graph. Does cosine start at the top or the midline? Cosine normally starts at the top. Why will this one not start at the top? Because there's a negative in the front. So remember, that negative right there is going to reflect your wave upside down. So instead of me starting at the top, like cosine usually does, I would start at the bottom at -2. And then I'm going to hit middle, top, middle, bottom. And then connect your graph. Okay, but we know it keeps doing that past that point. We're just looking at one full period, which would be from here to here. Okay. All right, now let's find your new period. What is the normal period for the parent graph? How many? 360. So if I want my new period, I'm going to do 360. And then I'm going to change it with whatever number is between the parentheses. What's between the parentheses? 2/3. Then I'm going to times by 3/2. Because remember, whatever number's in this position, you want it to have the reverse effect. So 2/3 means times 2 divided by 3. Then I want it times by 3 divided by 2. So put that in your calculator. What is my new period? Very good. Times 3/2 is 540 degrees. Okay, now quick question. If I'm already at 150 and I add 540 degrees to that, where should my wave end? This should be 690. Because remember, 540 degrees, the period is how long it takes to do one full wave. Okay, then if I want to break this up, remember I divide that by 4 and then I can measure what each space would be. So what is 540 divided into 4 equal pieces? 135. So in your calculator, type in a 150, then add 135 to that. What's my next marker? 285. Okay, then I'm going to start at 285 and I'm going to add 135 to that. That puts me at 420. Then I'm going to do 420 plus 135. That puts me at 555. And then if I add 135 to that again, I get my same 690. Okay, which is exactly what I was expecting to get by the end of the way. Does that make sense? All right, so because this week has been kind of weird, okay, you do not have a Delta Math on this assignment. Instead, you should have picked up your test review, okay, and you don't have a test next class, but instead of having like homeworks on each lesson, okay, you're just going to start working on the test review as you want to, okay? So let me tell you which ones off the test review you can do. Does anyone need it? Okay, you do still have a while though before your test. I'll have it. I'll have it. No? You got it? Do I leave it? All right, I'm going to tell you which ones to circle for today, okay? You cannot do any of the first page. Go ahead and turn it. You can do numbers 7 and 8. Circle them. Okay, then turn the page again. You can do 10, 11, and 12. 7, 8, 10, 11, 12. Okay, and then really I would say that's good for today. Okay? So rather than a Delta Math, you're just going to do those 5. 7, 8, 10, 11, 12. Okay? And then you'll turn this in when you take your test, but it's still 3 B days away. So we're not about to have one. Okay?